Hello everyone. In this video, we are going to discuss electricity. Okay, so various concepts of electricity like electric current, electric potential, potential difference, Ohm's law, resistors in series, resistors in parallel, power, energy. Okay, all these concepts we are going to discuss. So please watch the video till the end. You will understand each and every concepts. First point. Okay, we talk about the conductor and insulator. See, in physics, we classify all the materials into basically three groups, three categories. One is conductor, other is insulator, and third one is semiconductor. Conductor means what? Which will allow the electric current to pass through them easily, like the metals, aluminum, iron, copper. So they are conductors. Insulator means what? Which do not allow, which does not allow electric current to pass through them, like non-metals, oxygen, carbon, nitrogen, okay, wood, plastics. Semiconductor, they will allow electric current on certain condition. So their conductivity lies between conductors and insulators. They are called as semiconductor like silicon and germanium. So no. So what happens in case of conductor? Why they allow electric current to pass through them? Because they have free electrons. You can see they have free electrons. Okay. So once you connect this conductor to a shell of positive and negative, so what happens? This will become positive. This will become negative. So electrons will be repelled in this direction. Yes or no? So current will flow in the opposite direction. This flow of charges, flow of electrons per unit time is called as current. So current is nothing but charge flowing per unit time. And SI unit of charge is what? A coulomb. And time is second. So suppose 1 coulomb of charge flows for 1 second. Then current is said to be 1 ampere. Is it clear? So SI unit of current is what? A ampere. A coulomb per second. Next, we talk about electric potential. Okay, when we talk about electric potential, it is nothing but a amount of work done to move a unit positive charge from infinity to a point. Suppose I want to know a potential of this point A. Okay, and so what we are going to do, we will take one charge, unit positive charge. Unit positive charge means any charge of unit magnitude, one value. Okay, very small test charge we can say, so which is there at infinity. So when we are going to move this charge from infinity to this point, we have to do some work right now. So that amount of work done by charge is called as potential. So we can say V is equal to W by Q. So where W is the work done, Q is the charge, and V is the potential. SI unit of work is what? A joule. SI unit of work is what? A joule. SI unit of charge is coulomb. SI unit of potential will be volt. So if 1 joule of work is done to bring 1 coulomb of charge from infinity to a point, then potential is said to be 1 volt. Potential of that point is said to be 1 volt. Being a good student should know the value of 1 electron. 1 electron has a charge how much? Minus 1.6 into 10 to the power minus 19 coulomb. Next, we talk about potential difference. So potential difference is with respect to 2 points. Okay, A and B is the are the 2 points. Let's take a charge Q is there which is present at A. I want to move this charge A from charge Q from A to B. So to move this charge, we have to do some work right now. So that amount of work done, okay, to move a unit positive charge from one point to other point is said to be potential difference. So we can write a potential difference is equal to WAB by S and of work is what? Joule only, and charge is coulomb. So if 1 joule of work is done to bring 1 coulomb of charge from one point to other point, then potential difference is also said to be 1 volt. So SI unit of potential difference is volt. Is it clear? Next concept, we talk about Ohm's law. Okay, what Ohm's told? At constant temperature, potential difference across the ends of the conductor is directly proportional to the current passing through it. It means if the current is more, potential difference is more. Okay, when you remove the proportionality, you have to put a constant. So V is equal to what? I into R. R is a constant of proportionality called as resistance. Okay, resistance of the wire or conductor. So R is equal to what? From here we can write V by I. Let's take this wire is there. If 1 volt is applied, which causes a current of 1 ampere. So we can write R is equal to V by I. V is what? 1 volt, current is 1 ampere. So 1 by 1 is what? 1 ohm. So SI unit of resistance is what? Ohm. SI unit is what? Ohm. This is a symbol ohm like this. Is it clear? Okay, what is resistance? Resistance is the opposition offered to the flow of charges. And SI unit is what? A resistance. SI unit is ohm. They may ask you 2 to 3 marks a factor affecting resistances. Okay, there are basically 4 factors which affect the resistances. First one is what? A length of the wire. How it is depending? How it affects the resistance of the wire is directly proportional to the length. It means if length increases, resistance of the wire also increases. So you have considered two wire, okay, of same area of cross section. Length is L1, length is L2. Resistance of this wire is what? R1. This wire is what? R2. If L2 is more than L1, so resistance R2 will be more than R1. Is it clear? So if the wire length is more, resistance will be high. Next is what? The area of cross section, or also say thickness of the wire. So resistance of the wire is inversely proportional to area of cross section. It means if area of cross section is more, resistance is less. It means if the two wires are there of same length, for a thick wire less resistance, thin wire more resistance. Is it clear? So you have taken the two wires. Okay, area of cross section A1 is there, which is less. Resistance is R1. Area of cross section is what? A2. Resistance is R2. If A1 is less than A2, so R1 will be more than R2. This less is the thickness, more is the resistance. Next factor is what? The temperature. So resistance of the wire is directly proportional to the temperature. Okay, when the temperature is more, resistance is also high. Is it clear? It means when you heat the wire, heat the conductor, so kinetic energy of the electrons increases, random motion increases. Because of that, the resistance of the wire also increases. And the last factor is what? The nature of material. Resistance of the wire obviously depend upon the nature of material. For conductor, it has less resistance. For insulator, more resistance. Is it clear? So once you combine, let's take this is equation 1, this is equation 2. Okay, so here we can see as what we learnt, resistance of the wire is directly proportional to the length and it is inversely proportional to area of cross section. Once you combine these two, so you can write R is equal to rho times of L by A. Okay, L by A. Here rho is called as resistivity. What is rho called as? Resistivity or a specific resistance. Or a specific resistance. Sometimes in the exam they may ask you define a specific resistance. So from here we can write rho is equal to what? R into A upon L. So now consider the length of the wire is 1 meter unity and area of cross section is also 1. So what we are going to get? Rho is equal to what? R into 1 by 1. So resistivity is nothing but resistance of the wire of unit length and unit area of cross section. Okay, when the length is a unity and the area of cross section is also unity, then resistance is equal to resistivity. Resistivity is nothing but a resistance of the wire. It is the inherent property of the material. It is not going to change with length or area of cross section. Okay, but it will change with the temperature, obviously. Okay, in electrical circuit, we are using some symbols also. Okay, see what will be the unit of resistivity. You see first. Okay, when we talk about the unit of resistivity, so we can see here from here rho is equal to what? R into A upon L. So what is SI unit of resistance? Ohm. SI unit of area is what? Meter square upon SI unit of length is meter. So meter and square get cancelled. So rho SI unit is what? Ohm into meter. Is it clear? Next we have conductance. When we talk about conductance of the wire, conductance is nothing but G. It is a reciprocal of resistance. And SI unit is what? 1 by ohm. That is we can write ohm inverse. Is it clear? Next we talk about conductivity. Conductivity is represented as sigma. Sigma is nothing but 1 by rho. 1 by resistivity. Reciprocal of resistivity. Okay na? So as you know that resistivity unit is what? SI unit is ohm meter. Means it will go up so ohm inverse, meter inverse. Or you can say Siemens per meter. Okay, that is the SI unit of conductivity. Is it clear? Okay, here we are going to learn some symbols used in the electricity. Okay, symbols. This is a symbol for wire, electric wire. Is it clear? Is there or not? Symbols is not there in the slides. Okay, electrical symbols you should know. Second one, this is the symbol of cell, electric cell. Okay, na? If two or more cells are connected, it is called as battery. And this is a battery. Okay, this is the symbol of open key. Okay, this is what a open key. Open key we write like this also, like this, or. Okay, closed key we are writing like this. Dot is there. Okay, or we are writing like this. This will join here. This one and this one. This is closed key. Closed key. Is it clear? Next we talk about the lamp or bulb. This is lamp or bulb. Okay. Okay, this is a symbol of wire crossing over. Okay, wire crossing. This wire and this wire are not touching. So wire crossing over. Wire crossing over. This is symbol. Okay, this is the symbol of a wire jointed. Wire jointed. These two wires are there which are jointed. A for what? Ammeter. Okay, this is a symbol of A is written means ammeter. Ammeter is a device which is used to measure the current. So no, and it is always connected in series in electric circuit. If you write volt, V for what? Voltmeter. Voltmeter is a device which is used to measure the potential difference, and it is always connected in parallel. Is it clear? G for what? Galvanometer. Galvanometer. Is it clear? Let's take some more symbol. This is a symbol of resistor. Okay. And this is the symbol of variable resistor. Variable resistor. So these are the basic symbols we will be using in the electric circuit. Now we are going to learn resistors in series. Okay. See, let's take try to understand. This is the one resistor and this is another resistor. If one end of this is connected to one end of this, so you get this like this right now. So such connections are called as series connection. One end of resistor is connected to the one end of other. That's is it clear? So once they are connected to a V volt, okay, so current I will flow through this. So this I current will pass through R1, same I current is going to pass through R2. Is it clear? Now in the series circuit, current is same. Try to understand. And whatever the V we are giving, so that will divide here and here. So that the potential divides. So V is equal to what? V1 plus V2. That you have to remember. Is it clear? So potential difference. Suppose whenever I current passes through R1, so what is the potential drop or potential difference across R1? That is V1. Nothing but I into R1. Similarly, whenever I current passes through R2, so there is a potential drop or difference across R2, that is equal to V2 is equal to I into R2. Yes or no? This is using Ohm's law. Now I want the equivalent resistance of this combination. So remove these two resistors, connect a RS, okay, which is having the equivalent value of series combination. So what is the potential difference across RS? So when you connect to the V volt, current is going to be same. I current is there, yes or no? So whenever I current passes to RS, so V is equal to I into RS, yes or no? So this is equation 1, 2, 3. Using 1, 2, 3 in equation A. Okay. So you can see equation A is what? V is equal to what? V1 plus V2, yes or no? So substitute the value. V is what? I into RS. V1 is what? I into R1. V2 is what? I into R2. So you can take I common here. So R1 plus R2 is equal to IRS. I get cancelled. Yes or no? If I get cancelled, so you will get the RS is equal to R1 plus R2. It means whenever two or more resistors are connected in series, equivalent resistance is equal to sum of individual resistances. And it will be always more than the resistance which are connected in series combination. Is it clear? Suppose R and R is connected in series. Okay, connected in series. So what is R equivalent to RS? RS is equal to what? R plus R, that is 2R. Is it clear? If suppose n R resistors are connected in series, n times it is there, this combination. N times is there. Okay, in the series if it is connected. So what is the RS? RS is equal to what? N times of R. Is it clear? Okay. Next we are going to discuss resistors in parallel. Try to understand first. Suppose there is a resistance R1, another resistance R2. Okay, na? If one end of this is connected to one end of this, and other end of this is connected to other end of this. end-to-end connections are called as parallel connections. You can see R1 and R2 are there. One end is connected to A, another end is connected to B. Similarly, R1 one end is connected to A, other end is connected to B. Yes or no? So this is what a parallel connection. In the parallel connection, okay, this is the V voltage applied across this. Yes or no? So current will pass through this shell. Here current will divide because two different resistors are there right now. So here current through R1 is, let's say, I1, and current through R2 is what? I2. Is it clear? I1 and I2. Here current division takes place. So I is equal to what? I1 plus I2. Consider this as equation A. And what you have to remember, potential difference across R1, R2, okay, is same. So that is equal to the V which is applied. So V1 is equal to V2 is equal to V. That you have to remember. Now what is the value of current which we are going to get through R1? By Ohm's law we know that I is equal to V by R, yes or no? So current through R1 is what? I1. I1 is equal to what? V1 by R1. Okay, now what is V1? V1 is nothing but V. So V by R1. Can we write or not? Yes. Similarly, what is the current through R2? I2. I2 is equal to what? V2 by R2. Yes or no? V2 is nothing but V. So I2 is what? V by R2. Now I am going to remove these two resistors. I want the equivalent resistance value Rp connected to the same V volt. So I current will pass through this. Yes or no? I current will pass through this. So what is the value of I? I is equal to V by Rp. V by Rp. Consider this equation 3. So using equation 1, 2, 3 in equation A. What is equation A? I is equal to what? I1 plus I2. Yes or no? What is I? I is equal to V by Rp. I1 is what? V by R1. I2 is what? V by R2. You can take V common. So V common means 1 by R1 plus 1 by R2. So this V, okay, and this V and this V get cancelled. So 1 by Rp we are getting 1 by R1 plus 1 by R2. Is it clear? You can further solve this one as we know, as we got 1 by Rp is equal to what? 1 by R1 plus 1 by R2. Take the LCM. LCM is what? R1 R2. So this LCM divided by R1 you get R1 cancel. So R2 into 1. This is R2 plus this divided by this R2 get cancelled. So R1 into 1 is what? R1. Okay, so Rp is what? Let's take the reciprocal. R1 into R2 divided by R1 plus R2. One point you have to remember that equivalent resistance in parallel, whatever we are getting, it will be always less than R1 or R2. Is it clear? Consider, okay, some problems are there. You can see 5 ohm and 15 ohm are connected in series. What is the resistance and what is the equivalent resistance and current? So they are in series. So Rs is equal to what? R1 plus R2, that is 5 plus 15, 20 ohm. Yes or no? So we will get the circuit like this. Rs is what? 20 ohm connected to how much? 100 volt. So what is the current? Current is equal to V by Rs. So V is how much? 100 and resistance is what? 20. So 100 by 20 is what? 5 ampere. Is it clear? Take this question. If 5 ohm and 15 ohm, okay, are connected in parallel and that combination is connected with 100 volt. So what is the current and equivalent resistance? So you can apply the formula 1 by Rp is equal to what? 1 by R1 plus 1 by R2. You solve this. 1 by Rp is equal to 1 by 5 plus 1 by 15. Take the LCM. 15 is the LCM. 15 divided by 5 will get 3. 3 into numerator, that is 3 plus 15 divided by 15 will get 1. 1 into numerator 1. So 3 plus 1, 4 by 15 will get, yes or no? So this is 1 by Rp. So you have to take the reciprocal to get the equivalent resistance. Yes or no? Here only mistakes children are generally doing. Okay, na? So Rp is equal to what? 15 by 4. You can see what is the value, 3.75. If you are getting the value less than the value of resistors which are connected in parallel, then only you can be sure that my answers are correct. Okay, before writing the final answer, you should cross verify the solutions. So what is the value of I? I is equal to V by Rp. Yes or no? So V is what? 100. Rp is what? 15 by 4. Let it be. Once you solve, you get a 26.6 ampere. Is it clear? Okay. Next we have the concepts of power. What is power? Power is nothing but rate of doing work. Work done by time is called as power. Is it clear? What is power? Rate of doing work. Work done by time. So P is equal to what? W by T. So it is defined as the rate of doing work. Yes or no? Power is what? Rate of doing work. Okay, SI unit of work is what? A joule. Time is what? Second. If 1 joule of work is done for 1 second, then power is said to be 1 watt. So SI unit of power is what? A watt. Okay, they may ask to define 1 watt. So power is said to be 1 watt if 1 joule of work is done for 1 second. Yes or no? Okay, how we got some other formulas are there. Try to understand. As you know that V is equal to what? W by Q. Yes or no? From here we can write that W is equal to V into Q. Okay, na? And we know that V is equal to what? Sorry, what do we know? I is equal to what? Q is equal to what? I into T. From this formula you can see current is equal to charge by time. So charge is equal to current into time. So you can put here Q is equal to what? I into T. So W we are going to get V into I into T. So what is the formula for power? W by T. So W is what? V I T by T. T get cancelled. So this is the formula for power. Whenever potential difference is given and current is given, we can use this formula. Is it clear? There are some more formulas. We'll see. This is the first formula. Power is equal to what? V into I. Next, we know that V is equal to what? IR. So we can write P is equal to IR into I. Multiply this, I into I become what? I square into R. This is another formula for power. If current and resistance is given, so power is equal to I square R. SI unit will be what? Watt only. Now we know that P is equal to V into I and I is equal to what? V by R. Substitute the value. So we can write P is equal to what? V square by R. Third formula is there. So when potential difference and resistance are given, we can use this formula. Okay, now fine. So this is the now power is what? Work done by time. So whatever the work is done, it is stored in the form of energies. We can write power is equal to energy by time also. So energy is equal to what? Power into time. Okay. So E is equal to what? P into T. We are going to find 1 kilowatt hour energy. So let's take whenever power is 1 watt, time is 1 second. So energy is what? 1 watt into 1 second. That is 1 joule. 1 into 1 is what? 1 joule. SI unit of any form of energy is what? Joule, children. So now, yes or no? So what is energy? Energy is said to be 1 joule. Okay, if a 1 watt power is consumed for 1 second. Actually, energy is the ability to do work. Is it clear? Now we'll see 1 kilowatt hour. Okay, as you know that energy is equal to what? Power into time. Assume power as 1 kilowatt and time is 1 hour. 1 hour is how much? 3600 seconds. Or we can write 3.6 into 10 power 3 seconds. Yes or no? 1 kilowatt we can write 1000 watt or 10 power 3 watt. Yes or no? So energy is what? Power into time. So that is power is 1 kilowatt and time is 1 hour. So that is equal to 10 power 3 watt into 3.6 into 10 power 3 second. So if you solve this, you will get a 1 kilowatt hour is equal to 3.6 into 10 power 6. See 10 power 3 and 10 power 3 become what? 10 power 6. 1 kilowatt hour is how much a joule? 3.6 into 10 power 6 joule of energy. Is it clear? The last concepts we have a Joule's law of fitting. Okay, what Joule told? Whenever I current passes through the conductor of having resistance R, so it gets heated or heat is produced. Heat produced is directly proportional to the square of current. It is directly proportional to the resistance and it is directly proportional to the time for which the current is flowing. So once you combine, we can write H directly proportional to I square RT. Once you remove the proportionality, you have to put a constant K. So H is equal to what? K into I square RT. K value you can assume as 1. H is equal to I square RT. Yes or no? SI unit of heat is what? Joule only. I hope you understood the concepts of electricity. If you have understood, please like the video, share this video with your friends, and don't forget to subscribe the channel. Thank you.